Another example, question 2, again about falling film. Okay, an aqueous solution containing 15 ppm organic contaminant A with molecular weight of 100. So you can write down Ca0 15 ppm, molecular weight 100 gram per mole. The removal of A from the solution is achieved through reaction with oxygen at 27 degrees C inside a vertical tube of 3 cm diameter. In the reaction, 2 moles of oxygen are consumed for every mole of A reacted. So, what is the stoichiometric reaction equation? So 1 moles A required 2 moles of oxygen. A plus 2O2 equal to product. So the reaction equation similar with the first example. Okay, then dia kata the reactor is vertical tube with 3 cm diameter. So we draw the tube. Okay, let's say the tube 3 cm diameter. So diameter D0, diameter overall D0 is 3 cm. Okay, the aqueous solution flows inside the tube from the top. So aqueous solution, liquid lah, from the top at average velocity of 12 cm per second. So velocity of liquid UL 12 cm per second and forms a falling liquid film of 2 mm thickness. So from the top liquid falling film mesti ada both side with the thickness of 2 mm. So 2 mm here, 2 mm here. So 2 mm thickness. On the inner wall of the tube. Betul lah, inner wall. So dekat mana dia punya inner diameter? So inner diameter from this point, so DI to this point. So gas phase is the inner diameter. So overall D0. Okay. Okay, what else? A gas stream containing 20% oxygen in nitrogen flows into the tube in a counter current direction. So 20% of oxygen in nitrogen. So sama lah, maksudnya 20% of oxygen in air. It flows into the tube in counter current. So oxygen from the bottom, O2. Okay, oxygen from the bottom, counter current direction at atmospheric pressure. Out of the total oxygen supplied into the reactor, only 2% consumed throughout the reaction. So only 2% consume, only 2% of oxygen consume actually. 2% of O2 consume. Consume. So maksudnya 98% oxygen remaining. Okay. So for question A, if no reaction takes place in the gas phase, so no reaction in gas phase, meaning that the reaction only occurred in liquid phase. So reaction in liquid phase. Estimate the tube length required to achieve complete removal of A in the following cases. Okay, for complete removal of A, determine the length. L. But based on the two cases given. Okay, the first one, the rate of reaction is limited by mass transfer of oxygen in the gas. And the second one, the diffusion of oxygen through the liquid limits the rate of reaction. So ada dua case, either it is mass transfer of oxygen limited, or diffusion of oxygen in liquid yang limited the reaction. So apa maksud dia? And for the overall reaction, assume diffusivity of oxygen is 0.1 centimeter square per second. So given diffusivity of oxygen DO2 0.1 centimeter square per second. Okay, first we need to determine D not given 3 cm. So we need to determine DI before we proceed with the calculation, because we already have the thickness. Okay, so DI, so ataupun next page lah, saya draw. Okay, determine the DI. Okay, determine inner diameter. DI. Okay, DI equal to D naught outer diameter minus total film thickness. Okay, so D naught 3 cm, total film thickness both side is 0.4 cm. So your DI is equal to 2.6 centimeter. Right, then we proceed with question A. Memang kita in question A. Question 1. A1. Okay. Rate reaction is limited by mass transfer of oxygen in the gas. Mass transfer of O2 in gas, limiting the reaction. First step, what we need to do is to write the mass balance equation ataupun assumption. Again, so the first assumption is mass transfer of oxygen in gas limiting the reaction. So this is one assumption. Another one is unmixed phase, and the reactor can be modeled as PFR. Reactor can be modeled as PFR. Okay, therefore, okay, another one, reaction in liquid phase. Right? Because dia dah beritahu dalam soalan, no reaction take place in the gas phase. So reaction in liquid phase. Okay, first step, what we need to do is to write the mass balance equation. Okay, mass balance, because the reaction is PFR, so U L. Okay, why? Because reaction is in liquid phase, even though it is limited by the mass transfer of oxygen in gas phase. Okay, UDCA L per dz equal to negative R minus A over V Lm Km in gas phase, Km of oxygen, mass transfer of oxygen in gas phase. CO2 in gas phase. So another, if you look at the overall mass balance yang ada equilibrium concentration, that term automatically negligible. So we just write the mass balance equation for mass transfer as this equation. So the term at equilibrium will be negligible. Alright. Okay, then next, because the reaction is mass transfer of oxygen limited, so this term negligible. Okay, negligible because it is too fast. So yang limiting the reaction is mass transfer of oxygen. Why negative? Okay, negative sign here, not positive, because oxygen still in gas phase. Oxygen will diffuse to the liquid phase. So maksudnya dia transfer from gas phase to liquid phase. So that's why negative, sebab loss of oxygen from gas phase. That's why the sign is negative here. Okay, then the overall rate, so simplify kan, UL dCAL per dz equal to negative A over V KMO2 in gas phase, CO2 in gas phase. So saya lupa tulis. So negative sign, negative because O2 lost from gas phase. Okay, so you can understand later if you look at the jalan kerja, dia punya schematic answer later. Alright. Okay, then we need to determine the unknown value. Okay, apa value yang tak ada? We need to calculate A over V. Concentration of oxygen in gas phase also we need to calculate. So we need mass transfer of oxygen also we need to calculate. So we need to calculate all the unknown value. So first we calculate the A over V, and then next calculate the mass transfer coefficient of oxygen, and then finally concentration of oxygen. Barulah kita solvekan the integration. Okay. Then calculate A over V. What is A over V? A over V is the interface area per volume. Interface area of where the reaction occur. Okay, so interface area or per volume of reactor A over V equal to, so interfacial area, so you can refer to the notes for interfacial area in falling film reactor, RIL divide with the volume of reactor. So volume where the reaction occur actually. R naught square minus Ri square L. Why we consider the interfacial area of liquid? Because reaction only occur in liquid phase. So that's why the volume, we just consider the volume of liquid. And also the interfacial area of the liquid surface where the reaction occur. Right. Then because we already calculate the inner diameter and also we have the outer diameter, so kita boleh tukar ke dalam sebutan diameter. So kalau kita tukar dalam sebutan diameter, it will equal to 4 di per d naught square minus di square. When we cancel out L and pi value. Alright. So simplify, you will get this equation. Okay. So A over V done. Later we just insert all the value. And then calculate Km. Calculate mass transfer coefficient. Km oxygen based on Sherwood number. So Sherwood number SHD, diffusivity of oxygen divide with internal diameter. Okay. Because gas is in gas phase, so we for mass transfer still in gas phase. That's why we use di here. Mass transfer in gas phase. Diameter of gas phase. Diameter of gas. Okay, then what is Sherwood number value? SHD equal to 8/3 because cylinder, tube bentuk cylinder. So Sherwood number 8/3 for laminar flow. Diffusivity given as 0.1 cm square per second. So just insert the value as 8/3, 0.1 cm square per second divide with 2.6 cm. So you will get the mass transfer coefficient of oxygen. And then next, calculate the concentration of oxygen. Calculate concentration of O2 in gas phase. So CO2 in gas phase, because 98% remaining, so 0.89 multiply with the concentration of oxygen at initial, CO2 at initial. Okay, because we want to calculate the remaining oxygen. So dia akan jadi 0.98 concentration of oxygen at initial, PO2 per RT. So 0.98. So 20% oxygen in nitrogen ataupun in air. So 0.2 multiply with 1 atmosphere. Divide with R rate gas constant in atmosphere 82 atmosphere centimeter cube per mole Kelvin, multiply with temperature at 27 degrees C equal to 300 Kelvin. So you get the concentration of oxygen in gas phase. Mole per centimeter cube. Okay, now we can solve the mass balance equation because we already have all the unknown value. So first, rearrange the equation. So apa yang you akan dapat bila you rearrange, because we want to calculate the length of reactor, so negative sign, jangan lupa negative, UL. So A over V, kita rearrange, you will get D naught square minus DI square over 4 as H diffusivity of oxygen, CO2 concentration of oxygen in gas phase. Alright, then DCA liquid phase, so integrate from CA0 to CA equal to DZ integrate from 0 to L. Okay, then solve the integration. Okay, then you will get and consider the negative sign, so you will get UL D naught square minus DI square per 4. So SH tu you masuklah value KM, ataupun you boleh calculate KM value dulu and then masukkan ni. Oh, yang ni saya dah masukkan KM formula as SH. So just insert the value SH DO2 diffusivity of oxygen, CO2, and then integration you will get CA0 minus CA. Sebab kita dah consider negative sign, you will get CA0 minus CA equal to L. So just insert all the value, then you will get the length of reactor. And don't forget that for complete removal of A, CA equal to 0. So you just insert the value of CA0. Okay, then make sure you change the unit of CA0 to SI unit first, not in ppm. So kena change the unit of CA0 to mole per centimeter cube. So CA0, calculate it in mole per centimeter cube, because given in the question is in ppm. Okay, then insert all the value, you will get the length of reactor.